Imagine sitting at your desk late at night. The glow of your monitor is lighting up the room, casting that familiar blue tint over everything.
Right, the classic designer midnight oil.
Exactly. And you've just finished designing this beautiful, intricate typographic logo. It's perfect. The kerning is flawless. The colors pop. But it just sits there.
Yeah, it's trapped.
It really is. It's flat on the screen, just a collection of two-dimensional pixels trapped behind a pane of glass. Now imagine reaching your hand straight through that monitor.
Oh, wow. That's a visual.
Right. Imagine wrapping your fingers around the text you just typed and actually pulling it out into the physical world. Imagine feeling its weight, tracing its edges, holding your digital idea as a solid object in your hands, casting a real shadow on your desk. Welcome to the deep dive.
I mean, it is such a powerful visual to start with. And what's truly remarkable for anyone working in design today is that we are no longer dealing in science fiction metaphors here.
Wait, really? It's that accessible now?
It absolutely is. That transition from a flat digital workspace to a tangible physical reality is entirely within reach.
Yeah.
Even for someone who has, never touched a complex 3D modeling program in their entire life.
That is just wild to think about. And that is exactly our mission today. We are tailoring this deep dive specifically for the learner, someone who is perhaps just starting their design career, or maybe a 2D veteran looking to aggressively expand their toolkit.
Yeah, someone who wants to break the glass of the monitor, so to speak.
Exactly. We want to do this without getting bogged down by learning an entirely new, incredibly complex software ecosystem from scratch. So we are going to break down the core foundational design concepts from Chapter 15.
Yes. Printing 3D files.
Right. Chapter 15, Printing 3D Files from an Incredibly Practical Source. It's a book called Adobe Photoshop CC Classroom in a book 2018.
It's honestly a brilliant foundational manual because it takes a tool most designers already know intimately, Photoshop, and reveals this hidden three-dimensional depth operating right beneath the surface.
It really does. And if you are listening to this and want to actually follow along with the exact files and exercises we are going to be tearing apart today, you absolutely should get your hands on this material. You can just grab the book, Adobe Photoshop CC Classroom, in a book 2018.
Highly recommend it, yeah.
We have made it incredibly easy for you. You can just buy the book by scanning the QR code of the book link provided in the description below. That book link is right here. Insert book link here.
It's going to make visualizing this so much easier if you have it in front of you.
Totally. And while you're checking out that link, I want to explicitly request that you follow us for more technical design breakdowns and career building content. We love taking these dense manuals, stripping out the jargon, and extracting the exact knowledge you need to, level up your portfolio.
That's the goal. And the trajectory we're going to cover today is a complete pipeline. We will begin by understanding how to properly set up a 3D environment within a 2D space.
Right, decoding the anatomy of that space.
Exactly. Things like meshes, materials, and lighting. Then, we will navigate the crucial differences between moving your camera versus moving your actual objects.
Which is, spoiler alert, where most beginners give up.
Oh, absolutely. It's the ultimate frustration point. But from there, we will assemble a specific portfolio project together, a luggage tag, positioning 3D elements with mathematical precision.
Love that.
And finally, we will tackle the print settings, the physics of exporting, and how to get your digital file shipped to your door as a physical object.
Okay, let's unpack this, because before we can start printing physical objects, we have to look at the leap from 2D to 3D. The source material starts with a lesson overview, getting us prepped to navigate a 3D space.
Setting the stage.
Right. But the very first instruction, before you even see a single 3D pixel, is to restore Photoshop's default preferences.
Yeah, that catches a lot of people off guard.
It really does. You start the software and immediately hold down Ctrl plus Alt plus Shift on Windows, or Command plus Option plus Shift on a Mac. It prompts you to delete the Adobe Photoshop settings file. And my instinct as a designer is to fiercely protect my settings.
You spent years building those up.
Exactly. I have custom brush panels, specific workspace layouts, personalized keyboard shortcuts. Why on earth wipe the slate clean just to start a 3D lesson?
Well, establishing a baseline is vital when you are venturing into a completely new paradigm within a familiar software.
Okay, I'm listening.
When you are learning the 3D capabilities of an application that you normally use for 2D, you want the workspace to behave exactly as expected. Over time, you might have inadvertently changed grid snapping behaviors, or allocated more RAM to specific history states.
Oh, or altered the way tooltips display, maybe?
Exactly. If a tutorial tells you to look for a specific 3D widget in the top right corner and your custom workspace has hidden that panel, the cognitive friction ruins the learning process.
That makes a lot of sense, actually. It's like clearing off a cluttered physical workbench before you begin a delicate new project. If I'm trying to learn watchmaking, I don't want my woodworking tools scattered all over the desk distracting me.
That's a great way to put it. By resetting those preferences, you guarantee that when you activate a 3D tool, it responds predictably. And once you understand the workflow, you can absolutely bring your custom brushes and layouts back.
Okay, so it's temporary.
Yeah, purely for the learning phase. It prevents software troubleshooting from getting in the way of conceptual understanding.
So the workbench is clear. We open Adobe Bridge, navigate to our lesson folder, and look at a file called 15n.psd. This is our target.
The holy grail of Chapter 15.
Right. And what we see is a 3D rendering of a red luggage tag with a slot cut out for a strap. Sitting on top of this tag is text that says, "Visit Paris."
And it looks incredible, right?
It does. It casts shadows, it has thickness, it catches the light differently on the edges. It just looks like a real, tangible product.
It's a very practical, concrete portfolio piece. But to get there, we have to address the elephant in the room regarding the software itself.
Yeah, because this is what I was thinking the entire time I was reviewing the source. Photoshop is world famous for photo editing. I mean, it's right there in the name.
Photoshop, exactly.
It's for compositing, retouching, masking, color grading. Why on earth are we using Photoshop to build 3D objects instead of a dedicated 3D program like Maya, Blender, or Cinema 4D? My fear is that we are using a butter knife to turn a screw.
I hear this all the time. And it's the right question to ask. But you have to realize, Photoshop has a very specific, basic set of 3D capabilities. It is not trying to compete with fully fledged, dedicated 3D animation suites.
So I shouldn't try to model the next Pixar movie in here.
No, absolutely not. Your computer would melt. These tools are mostly intended to create simple 3D objects like extruded text or basic geometric shapes. Or, and this is crucial, to integrate existing complex 3D models into a 2D Photoshop composition.
Oh, I see. So it's about integration rather than starting a massive new workflow from scratch. Like, if I have a 2D photo of a desk,
Yes, exactly.
I can use Photoshop's 3D tools to drop a 3D coffee mug onto that desk, match the lighting, and blend them seamlessly.
Precisely. The barrier to entry is the key factor here. For a beginner designer, opening up a dedicated 3D modeling program can be paralyzing.
Oh, yeah. The interfaces look like the cockpit of a jet airliner.
They really do. There are hundreds of new tools, entirely new paradigms of rendering engines, node-based material editors, and complex physics simulations. It's overwhelming.
It's too much all at once.
Right. So by keeping you within Photoshop, an interface you already understand, with layers and masking tools you recognize, the software is offering you a bridge. It allows you to learn spatial relationships, the z-axis, lighting, and textures, without the cognitive overload of learning an entirely new software language simultaneously.
I love that framing. It's a stepping stone. It's, the training wheels for spatial design. Okay, so we have our clean workbench. We know our goal, the Visit Paris luggage tag, and we understand why we're using Photoshop to do it. Now we have to actually build the invisible architecture of this 3D space, which means we need to decode the anatomy of the 3D environment.
And this is where the paradigm shift happens for most users. In traditional 2D Photoshop, a layer is essentially a flat piece of glass with some paint on it.
Right, you just stack the glass.
You stack the glass, you look down from the top, and you see your composite image. But a 3D layer is fundamentally different. It operates on entirely different mathematical principles.
The vocabulary introduced here is pretty dense. The source material says a 3D layer contains one or more meshes, and a mesh defines the 3D object itself.
Think of the mesh as the mathematical wireframe. If you create a 3D cone, the mesh is the underlying geometric structure that makes it a cone and not a sphere or a cube.
So it's just the shape.
Just the shape. It's a collection of vertices, edges, and faces in digital space. But a mesh alone is just invisible geometry. If you rendered it without anything else, you wouldn't see anything. It needs an appearance.
Okay, right. And that's where materials come in. Each mesh includes one or more materials which dictate the appearance of the mesh, and then it gets even more granular, which is where I honestly started to get a little overwhelmed.
It's a lot to take in.
It is, because it says materials are made of maps. There are 9 typical maps, which are the components of the appearance. And finally, each map contains a texture, which is the actual image defining what the maps and materials look like.
Like a simple bitmap graphic or even a set of regular layers, yeah.
Plus, the 3D layer has lights that stay fixed as you spin the object, and cameras, which are saved views.
It is a tremendous amount of complexity nested inside a single layer on your Photoshop screen. To a 2D designer, this hierarchy mesh, material, map, texture can feel incredibly abstract.
The only way I could wrap my head around it was to think of it like a miniature movie set contained entirely inside a regular Photoshop layer. Let me try this out on you because I need to make sure I have this hierarchy right.
Please, let's hear it.
Okay, so the 3D layer itself is the soundstage, the entire building. Inside the soundstage, you have your actor, the actor's physical body, their shape, how tall they are, their skeleton. That is the mesh.
The structural form, that tracks perfectly.
Right. But you can't just film a skeleton. The actor needs a costume, the overall outfit they are wearing, the aesthetic vibe of the character. That is the material.
Yes.
But a costume is complicated. It has different components. Maybe the jacket needs to be shiny leather, but the shirt underneath needs to be dull cotton, and maybe there's a bumpy pattern on the tie. Those individual instructions, how shiny, how bumpy, how reflective, those are the maps.
Exactly. In 3D rendering, you have specific maps for specific optical illusions. You have a diffuse map for the base color, a specular map regulating reflectiveness, a bump or normal map regulating surface texture.
All working together.
Right. There are up to 9 of these regulating every single aspect of how light interacts with the surface.
I want to pause on bump maps for a second because that absolutely blew my mind when I realized how it works. A bump map doesn't actually change the physical mesh, right?
Not at all.
If I apply a bump map of a brick wall to a flat plane, the mesh itself remains a perfectly flat pane of digital glass. But the bump map is usually a black and white image. It tells the software, when virtual light hits this flat surface, pretend the white areas are raised and the black areas are indented, and draw fake shadows accordingly.
Yeah, it's completely wild.
It tricks my eye into seeing 3D texture on a flat surface.
That is exactly how it works.
Yeah.
It's an optical illusion calculated by the rendering engine to save processing power. Changing the actual geometry of the mesh to include millions of tiny bumps would crash most beginner computers immediately.
Instant blue screen of death.
Exactly. So we use maps to fake it.
It's genius. So, back to the analogy. We have the skeleton, which is the mesh. The costume vibe is the material. The instructions for how the costume reacts to light are the maps. And finally, you have the texture.
Lowest level.
Right. The texture is the literal fabric you cut to make the costume. It's the actual JPEG image of the leather grain or the plaid pattern. And just like in real life, you can use the same roll of fabric, the same texture image, to feed different maps for different materials.
The analogy holds up incredibly well. And just to finish out the movie set, the 3D layer also contains the lights, which are studio rigging hanging from the ceiling, casting fixed illumination on your actor.
Ah, right.
And the cameras are the director's lenses placed at specific angles around the set to capture the action.
So when you look at your layers panel in Photoshop, you might just see one single row that says Layer 1 3D. But inside that one little row is the entire soundstage, the actor, the costume, the lights, and the camera.
And what's fascinating about this architecture is how Photoshop handles it on a macro level. Despite this immense nested complexity, Photoshop treats this 3D layer just like any other layer.
Really, just like a normal text layer.
Pretty much. You can still apply regular layer styles to it, like a drop shadow or an outer glow. You can apply a standard 2D layer mask to it. It sits in your layer stack just like a flat photo would.
That's wild to me. I can have a fully rendered 3D sports car, and I can just, take a soft black brush on a layer mask and paint out the back half of the car.
Yep, and blend it seamlessly into a 2D background.
That is just incredible.
It bridges the gap between the familiar 2D tools and the new 3D architecture. It allows you to leverage everything you already know about Photoshop compositing while integrating volumetric objects. Now, there is a very interesting tip provided in the text regarding Adobe Dimension CC.
Yeah, I noticed that. It explicitly tells the user that if a window opens describing Dimension CC, they should just close it for now. It feels a bit like, pay no attention to the man behind the curtain.
It does feel like that, but it adds a crucial caveat. It says if 3D becomes an important part of your work, Dimension CC is something you should explore later.
What does Dimension CC actually do?
Dimension makes it easy for graphic designers to create high-quality, photorealistic 3D images, build product shots, and composite 2D and 3D assets much more robustly.
My question is, why bring up a totally different piece of software right as I'm trying to focus on Photoshop's 3D? Is Photoshop's 3D already obsolete?
Not obsolete, no, but specialized differently. The mention of Dimension CC is about managing your expectations and outlining a career trajectory.
Okay, how so?
Photoshop's 3D environment is a stepping stone. It is giving you the foundational vocabulary: mesh, material, map, camera, lighting. Once you master this vocabulary here on your familiar workbench, you will eventually outgrow it if your primary job becomes, say, rendering photorealistic product packaging.
Right, if I start doing that all day, every day.
Exactly. When that day comes, a dedicated staging tool like Dimension CC is the logical next step. But the concepts you learn right now in this Photoshop environment will transfer perfectly.
That is a vital perspective for someone building their career. You learn the concepts where it's safe and familiar, and then you carry that knowledge to the specialized tools when your ambition outgrows your current sandbox.
That's the perfect way to look at it.
Okay, so our movie set is built, we understand the vocabulary, but now we actually have to step onto the set and start moving things around. We need to learn how to navigate this space without accidentally knocking over all the props.
This is where the physical interaction with the software changes dramatically. The workflow guides you through creating a very simple object to practice on first.
The blue cone.
Right, you create a new document, fill the background layer with a vivid blue color, and then you transform that flat blue layer into a 3D object. You go to the menu, select 3D, then new mesh from layer, then mesh preset, and finally cone.
So your flat blue rectangle instantly wraps into a 3D blue cone sitting on a digital grid.
And the moment that happens, the interface adapts. You see a secondary view window pop up, a camera widget appears, and importantly, you must select the Move tool from the Tools panel.
The regular old Move tool.
The very same.
Yeah.
The 3D capabilities are embedded directly into the familiar Move tool. It recognizes when a 3D layer is selected and changes its function completely.
But this introduces what I think is the most crucial and frankly the most frustrating workflow rule for a beginner. It's the difference between moving the camera and moving the object.
Oh, it is the single most common stumbling block. When you have the Move tool selected, its behavior changes entirely based on where your cursor is when you click and drag.
Okay, so break that down for me.
If you click the edge of the cone, or just outside it, meaning not on the solid object itself, and you drag, you move the camera.
Just the camera?
Yes. You might use the pan mode to move your viewpoint side to side, or the orbit mode to rotate your view completely around the cone. You are just changing your perspective. The cone itself hasn't moved an inch from the center of the grid.
But if you click directly on the cone itself, the object becomes selected. Now the Move tool stops editing the camera and starts transforming the physical object within the space.
Right. If you drag now, you are shoving the cone across the floor.
I can see how infuriating that would be if you didn't know the rule. Imagine you are trying to adjust your view to see the back of the cone. You intend to just orbit your camera, but your mouse slips, you accidentally click the edge of the cone itself, and suddenly you've dragged the cone 10 feet to the left, completely ruining your meticulously aligned layout.
Which is why there is a strict warning in the book. It's important to drag outside any objects when using the 3D camera modes. You are essentially deciding whether you are the director walking around the set or the stagehand picking up the prop and moving it.
You have to be incredibly deliberate with your mouse clicks.
Very deliberate.
Let's talk about the tool the stagehand uses. When you successfully select the object, this multicolored compass pops up inside it called the 3D axis widget.
Yes, the widget.
It has 3 distinct colors: red, green, and blue.
The classic RGB color model.
Here's where I get stuck on UI design, honestly. Red represents the x-axis, green represents the y-axis, and blue represents the z-axis. Why do software developers use these colors?
You prefer letters?
Yes. Why not just put giant legible letters X, Y, and Z floating next to the arrows? It feels like an extra layer of translation that my brain has to do while I'm already struggling with spatial coordinates.
It's a very common complaint from beginners, I'll give you that. But there's a deeply rooted physiological reason for this design choice. The RGB color model corresponds directly to the XYZ axis. RGB maps perfectly to XYZ. Red is X, green is Y, blue is Z.
Okay, the mnemonic helps. But again, why not just use the letters?
Because of immediate visual processing in complex environments. When you have a complex 3D scene, imagine a fully rendered architectural visualization with multiple buildings, trees, and intersecting geometric shapes. Letters can become a nightmare.
How so?
A letter Z can be distorted by perspective as the camera tilts. It can be hidden by shadows, or it can become completely unreadable against a busy, high-contrast texture map of a brick wall.
Oh, that's true.
Colors, however, register instantaneously to the human eye, regardless of the angle, the perspective distortion, or the background noise.
That actually makes perfect sense. If I see a sliver of red peeking out from behind a building, I immediately know that's my horizontal axis, even if I couldn't possibly read a letter on it.
Exactly. RGB to XYZ is a universal spatial language used across almost all 3D software, from Photoshop to Maya to game engines like Unreal. Once you internalize that red is always horizontal for X, green is always vertical for Y, and blue is always depth for Z, your brain stops having to read and just starts reacting.
So let's look at the mechanics of this widget. It's not just a set of colored lines, it's a multi-tool. Every part of it does something different.
It is deeply functional. If you position your pointer over the little box at the very center of the widget, it turns yellow. Dragging that yellow center box scales the object uniformly.
So it makes the whole cone bigger or smaller in all directions at once.
Right. And then there are arrows at the extreme end of each axis.
What do those do?
Dragging the arrow at the end of an axis moves the object exclusively along that specific line. If you grab the green arrow, you're moving it straight up or straight down on the y-axis.
Oh, I see.
The software locks it so it cannot drift horizontally or slide backward into depth. It ensures mathematical precision, which is impossible to get if you're just free dragging.
That's incredibly useful. And finally, there are these curved handles just inside the arrow.
Those control rotation. Grabbing the curved handle on the red x-axis will spin the object around that axis, tumbling it forward or backward like a gymnast on a high bar.
It's brilliant, compact UI design, but there is a massive beginner trap with this widget that we need to highlight. The 3D axis moves with the object.
Yes, the orientation of the widget is tied to the object's local space, not the global space of your screen.
Right. If I take that cone, grab the curved handle on the y-axis, and spin the cone 180 degrees so the front is now facing backward, the blue z-axis arrow, which normally points toward me, is now pointing directly away from me, buried entirely inside the cone's geometry.
And if you can't see the part of the widget you need, you can't click it.
It's just gone.
It might be at a hard-to-see angle or hidden by the object itself. You might have to temporarily stop moving the object, switch back to moving your camera, orbit all the way around to the back of the cone, just so you can physically see and grab the blue arrow.
It's a constant spatial puzzle. You have to be hyper-aware of where you are in the room, where the object is facing, and where the handles are pointing, which is why knowing how to quickly reset your view is a lifesaver.
Yes, the presets.
You can right-click the camera widget in the lower left corner of the screen and choose presets like top, left, or front.
This is a critical workflow efficiency. Instead of manually dragging the camera with your mouse and trying to eyeball what is perfectly straight down from above, you just use the preset. The camera snaps to a mathematically perfect top-down orthographic view.
That is so much faster.
It is, and it's important to note the distinction here. When you change the camera angle via these presets, the object itself does not move. Only your perspective changes.
Okay, so we've practiced all of this on a basic blue cone. We've built the set, learned the vocabulary of meshes and materials, and figured out how to move around without accidentally grabbing a prop. Now, it's time to apply this to our actual portfolio project. We need to position the elements for our luggage tag.
This is where theory becomes practice. You open the file 15start.psd.
Right, and when you open it, you find two 3D elements floating in the space. You have the extruded text that says, "Visit Paris," and you have a solid red plastic tag with a slot cut out for a strap.
But they are a mess.
A total mess. The text is in an awkward position, floating haphazardly and overlapping the tag incorrectly. It's our job to align them perfectly so it looks like a single manufactured object.
And this requires a very different level of patience and precision than 2D design.
How so?
Well, in a standard 2D Photoshop workflow, you want to move some text over a red rectangle. You just grab the Move tool, click anywhere generally near the text, and drag it. It's loose, it's forgiving.
But in 3D space, you cannot afford to be sloppy. As you position the Move tool over the text, you absolutely must not click until the object's 3D bounding box appears around it.
That is vital, because a 3D object only becomes selected when you click a solid part of that mesh, not the empty spaces around it, and crucially, not the empty spaces within it.
This is exactly what I meant by the hole in the letter P or the letter A. In a 2D layer, if you click the empty space inside an O, Photoshop usually knows you mean the text layer because it recognizes the overall bounding box of the type. But in 3D, if you click the empty space inside the P in Paris,
you are clicking straight through the text mesh. Your click travels through the empty space and hits the background behind it.
Oh.
Consequently, you will end up grabbing the background and moving your camera instead of moving the text. It is incredibly disorienting.
It's like parallel parking a car. You can't just grab a 2D sticker of a car and slap it onto a picture of a street. You are dealing with physical volume. You have to wait for the system's sensors, the bounding box, to recognize the spatial boundaries of your car before you can put it in gear and move it along a physical track.
That's a highly accurate way to visualize it. So you wait for the bounding box around Visit Paris. You deliberately click a solid, thick part of a letter to activate the 3D widget.
And then,
following the rules we just discussed, you hover over the tip of the green arrow until the Move on Y-axis tooltip appears.
right, you click that green arrow and drag the type down to center it vertically on the red tag. Then you click the tip of the red arrow, the X-axis, and drag it right to center it horizontally.
Notice the discipline required here. You are forced to use the single-axis arrows, rather than just grabbing the center of the widget and dragging freely.
Honestly, my instinct is absolutely to just grab the text and drag it diagonally to the center in one fluid motion, just like I would on a 2D canvas. Why is that a bad idea?
Because in 3D space, depth perception on a slat 2D monitor is incredibly deceptive. If you grab an object freely by its center and drag it diagonally, you might think you are moving it perfectly down and to the right across the surface of the tag.
That's what it looks like on screen.
But because you are moving in unconstrained 3D space, you might actually be moving it down, to the right, and 3 inches backward into the Z-axis.
And suddenly the text disappears entirely because I've accidentally shoved it completely inside the solid geometry of the red plastic tag.
Exactly. Or you've pulled it 3 inches forward so it looks centered from the front. But when you rotate the camera, you realize the text is hovering magically in midair above the tag.
Right, floating away.
By forcing yourself to use the colored axis arrows one at a time, you lock out the depth. If you only pull the green and red arrows, you ensure the text slides perfectly flat along the original plane without sinking into the object or floating away from it.
That disciplined precision is everything. That's what separates a messy, frustrating file from a professional asset. And once we have it perfectly aligned, the text is sitting beautifully flush against the tag. We save it as 15working.psd. Our digital design is finished.
Which brings us to the most magical and frankly the most futuristic part of this entire process. We have perfectly aligned pixels on a screen. Now, how do we turn those pixels into actual physical plastic?
This shift from digital to physical is profound. When we normally think of printing from Photoshop, we think of a flat page coming out of an inkjet printer. It might be high resolution, the colors might be perfectly calibrated, but at the end of the day, it's just ink on paper. You can't view it from different angles, you can't feel the typography.
But 3D printing creates the thing itself.
Yes, this technology opens up massive fields. We are talking about medical uses like printing custom prosthetics, rapid prototyping for industrial design, creating intricate custom jewelry, or just making one-of-a-kind souvenirs. There is a whole rise of DIY maker spaces where you can rent time on these incredibly expensive machines.
It represents the true democratization of manufacturing. You don't need a factory in another country to produce a prototype anymore.
But this raises a very practical question for the listener today. If you are a beginner designer or even a mid-level professional, you probably don't have a $5,000 FDM or resin 3D printer sitting in your home office. So how do you actually utilize this technology right now, today, to build your portfolio?
This is where the direct integration within Photoshop becomes so powerful. To start this process, you have to ignore the standard file, then print menu that you've used 1,000 times. You have to go to a specialized menu, 3D, then 3D print settings.
And when you open the Properties panel there, Photoshop offers the ultimate solution for the printerless designer, Shapeways.
Shapeways is an online 3D printing service bureau. They have industrial-grade 3D printers, they print your objects, and they mail them to you for a fee. What makes this workflow remarkable is that Shapeways is integrated directly into Photoshop's Print To menu.
This blew my mind when I read it. You don't have to blindly export a file, open a web browser, search for a vendor, worry about format compatibility, and just hope the geometry doesn't break in transit. Photoshop has built a direct pipeline. You select Shapeways right there in the Properties panel.
And once you select the vendor, you have to select the material. This is where you can start making incredibly sophisticated design choices. One specific material choice highlighted in the book is plastic alamide.
I had to look this up. Alamide is a blend of nylon plastic and actual aluminum dust. It simulates the look, the slight sparkle, and even some of the tactile feel of metal. When you select it in the menu, your preview in Photoshop actually updates to show a silver gray tag with extruded text. simulating how light will react to that specific physical material.
Think about the implications of this for a moment, especially for someone trying to break into the industry and build a standout portfolio. You are designing a premium brand asset, a luggage tag for Visit Paris. If you print that out on flat photo paper, it looks like a standard student project. If you print it in cheap, shiny red PLA plastic on a cheap home printer, it looks like a Happy Meal toy.
But Alimide simulates luxury metal. For a relatively low cost, you can have a physical, metallic-looking prototype of your custom typography manufactured and sent to your house. You can take that physical object, place it on a nice wooden desk, photograph it in natural sunlight, casting real physical shadows, and put that photograph in your portfolio.
It elevates your work from a theoretical digital concept to a tangible physical product. That is a massive game changer for landing a job or pitching a client. It demonstrates that you don't just understand software, you understand production, physical materials, and real-world application.
It proves you can design for reality. But before Shapeways can manufacture it, our file has to be prepared for the harsh realities of the physical world. Digital objects on a screen don't have weight. They don't have structural integrity. Physical objects have to obey the laws of physics and gravity.
We have our silver gray Alimide preview, but we need to ensure the machine can actually build it without it collapsing into a pile of molten dust. The first physical constraint we have to deal with is size.
The settings discuss printer units ensuring inches or millimeters is correctly selected. It explains that every 3D printer in the world has a maximum capacity, a physical, enclosed box within which it can build.
This is referred to as the printer volume.
Right, and your digital object size is the scene volume. Photoshop actually shows you a faint cube outline in your workspace representing the printer's maximum limits. If your digital luggage tag is accidentally scaled to be 3 feet wide because you weren't paying attention to the math, but the printer can only print objects up to 10 inches wide.
You have a catastrophic failure.
Exactly, it just won't fit.
But Photoshop provides a one-click fix for this geometry problem: the Scale to Print Volume button. It mathematically calculates the maximum dimensions of the printer and perfectly shrinks your entire scene to fit safely inside that capacity without distorting the proportions.
That's a lifesaver.
For our luggage tag project, it's already comfortably smaller than the volume, so we are safe. But it's a vital safety check.
Size is one issue, but structural integrity is the real challenge. The mechanics of how 3D printers actually work introduce a fascinating engineering problem. Most consumer and mid-range industrial 3D printers build objects from the bottom up, extruding material layer by microscopic layer.
Right, and if you are printing a simple geometric cube, it's incredibly easy. It has a flat, solid base that sits directly on the printer bed. The printer just stacks layer upon layer of material straight up. But reality is rarely a perfect cube. To explain when things get complicated, consider printing a model of a four-legged animal.
This analogy perfectly illustrates the problem. The animal's bottom is composed of 4 separate feet touching the ground.
Exactly. The printer starts successfully, it prints the hooves, then it slowly builds up the 4 individual legs. But eventually, the printer reaches the height of the torso. The printer nozzle has to move into the empty space between the front and back legs and start depositing molten plastic to create the animal's belly.
It is trying to extrude liquid material into thin air, and physics dictates that molten plastic extruded into thin air with nothing beneath it will simply fall to the printer bed, ruining the print entirely. Gravity always wins.
So how do you solve for gravity when the design inherently requires overhanging elements?
The printer requires a temporary support structure. There are 2 specific terms introduced here: a raft and scaffolding. A raft is exactly what it sounds like. It's a temporary, thick base printed directly on the printer bed to provide a stable, perfectly level foundation for the actual object to sit on.
And scaffolding represents the temporary support columns. The printer builds little brittle pillars up from the raft underneath the overhanging parts of your object, like underneath the animal's belly.
Like little crutches.
Exactly. So when the nozzle starts extruding the belly, the plastic has a temporary solid surface to rest on while it cools and hardens. Once the print is finished and cooled, you take the object and physically snap or dissolve the scaffolding off.
It requires cleanup, maybe some sanding, but it allows impossible shapes to exist. What I marvel at is the fact that Photoshop calculates this gravity for you. You don't have to manually draw little support pillars under the curve of the letter P.
Right, the software handles it.
When you prepare the 3D print, Photoshop's engine analyzes the geometry, calculates the physics of the chosen material, and automatically generates exactly where the raft and scaffolding are needed to prevent a collapse.
It takes an immense engineering burden off the designer. You can focus purely on the aesthetics of the typography, and the software handles the structural engineering required to make it real. Now, for our specific luggage tag, because it is designed to lie perfectly flat on its back, it requires no raft or scaffolding, so those options appear dimmed out in the preview.
So the physics are calculated, the size is correct, the material is chosen. Now we just have to export it to the manufacturer.
You initiate the final process by clicking the 3D print icon. Photoshop begins preparing the job. Depending on the complexity of your mesh and the speed of your computer, this might take some time because the software is performing intense geometric math to slice the object into printable layers.
Once that math is done, a dialog box pops up giving you an estimated price based on the volume of material required.
You then hit export, and you save the file as 15working.stl. STL stands for stereolithography, and it is the universal standard file format for 3D printing. Photoshop packages it up, zips it to compress the file size, and then immediately prompts you to upload to the Shapeways site.
You log into your account, upload the zipped STL file, and Shapeways processes it. It shows you an interactive 3D preview of your model on their end, alongside a comprehensive list of materials, everything from plastics to cast metals, with their exact real-time manufacturing prices.
And here is the crucial reassurance that every beginner needs to internalize. You are not committed to a purchase until you enter your credit card, check out, and pay.
That detail is so important because it makes this an entirely risk-free environment. You can design an intricate architectural model, a custom action figure, or complex typography. You can run it through the print settings, let Photoshop generate the scaffolding, upload it to Shapeways, and just see what it would cost to print in solid titanium versus cheap nylon.
It's all just research at that point.
You can test your designs against real-world manufacturing constraints and budgets without spending a single dime.
It fundamentally transforms Photoshop from a simple drawing tool into a manufacturing sandbox. You can iterate purely to understand production costs.
It really does. Okay, we have covered immense ground today. We've gone from resetting software preferences to calculating the structural integrity of 3D printed metal. To wrap this up, instead of doing a literal pop quiz, I want to frame the core takeaways as a pre-flight checklist.
I like that idea.
These are the 4 fundamental paradigm shifts a designer needs to internalize. If you understand these 4 pillars, you can legitimately look an employer or a client in the eye and say, yes, I know how to navigate and integrate 3D within Photoshop.
I agree completely. Let's solidify that foundation.
Yeah.
Pillar number 1 is understanding the true nature of a 3D layer.
Right. On the outside, in the Layers panel, it behaves like any other layer. You can apply a 2D layer mask, you can apply layer styles like drop shadows, you can adjust its opacity.
But on the inside,
But on the inside, it is a nested universe. It contains meshes which define the structural geometry, materials which dictate the aesthetic vibe, maps which trick the lighting engine into seeing bumps and reflections, and it houses its own internal lighting and camera setup.
Perfectly summarized. Pillar number 2 is mastering navigation, specifically the dual nature of the Move tool.
The director versus the stagehand. If you click anywhere outside the physical bounds of the object, you are the director. You are panning and orbiting the camera, changing your perspective, but the set remains untouched.
And if you click the object,
If you wait for the bounding box and click a solid part of the object itself, you become the stagehand. You are now physically moving the object within the space. Clicking the wrong pixel changes everything.
pillar number 3 is the essential spatial mnemonic, the 3D axis widget.
RGB maps perfectly to XYZ. Red is the x-axis for horizontal movement. Green is the y-axis for vertical movement. Blue is the z-axis for depth. By memorizing those colors, your brain skips the step of trying to read tiny letters in a cluttered interface, and you can instantly grab the correct arrow to constrain your object's movement to a single plane. If you use the arrows, you will never accidentally bury your text inside another object.
And finally, pillar number 4, translating digital math to physical mass.
You cannot just hit Command P and expect a physical object. You must navigate to a dedicated workspace. 3D, then 3D print settings. Here, you establish your printer's physical limits to avoid scaling disasters, select your material to simulate reality, and allow the software to calculate gravity by generating necessary rafts and scaffolding. Only then do you export the STL file to a service bureau to bring it into the real world.
Those 4 pillars give you complete conceptual control over the physical pipeline, hidden inside a tool most people only use for retouching photos.
This has been incredibly revealing. We've taken a 2D software and unlocked a manufacturing plant inside of it.
If we look at the broader implications of what we've unpacked today, I want to leave you with a final thought to mull over as you close out of this deep dive. We started with the dream of reaching into your monitor and pulling a digital design out into the real world. You see now that the mechanics, the physics engines, and the supply chains to do exactly that are already sitting on your hard drive waiting to be used.
It's all right there.
If a simple flat text layer typed out on a keyboard can be transformed into a physical metallic luggage tag that gets shipped to your front door in a box, how does knowing that change the way you look at your 2D portfolio right now? As you scroll through your past logos, your illustrations, your typography, what else have you drawn that deserves to cast a real shadow in the real world?
That is the perfect question to end on. What deserves to become real? Thank you all for joining us on this deep dive. As a reminder, every concept, workflow, and technical detail we tore apart today comes from the incredible resource, Adobe Photoshop CC Classroom in a book 2018.
Good must have.
You absolutely should add this to your reference library if you want to follow along with the exact files. The book link is right here. Insert book link here. Remember, you can buy the book easily just by scanning the QR code of the book link provided in the description below. And please do not forget to hit follow for more technical design breakdowns and career-building content. Keep designing, keep exploring the Z-axis, and we will see you on the next deep dive.